Let's move on to the next topic, that is list rendering with @4. When it comes to looping over collections and displaying them, Angular uses the @4 control flow syntax. We have seen this syntax some time back once when we displayed the individual ingredients for the recipe. What it needs is a special track expression that helps Angular to optimize performance by uniquely identifying each item in the list. In fact, the project exercise we have is also the same task where in the recipe detail component, we need to loop over the ingredients array and display each item. Since that was already done in one of the previous challenges, let's inform Gemini CLI that the same is already available. It says, excellent, you have successfully refactored your recipe detail component to use the @4 block for the ingredient list, ensuring a clean and efficient rendering of the dynamic data. Let's move on to the next topic, module 12, which is conditional rendering with @if. If you have ever written an if-else statement in JavaScript, you already know this concept. It's that simple. If we need to display or hide parts of the UI based on certain conditions, the @if control flow syntax help with conditional rendering. We could also use the @else and @elseif to handle multiple conditions. Here is a simple example where based on the signal value of is logged in, specific messages are shown in the template. If the user is already logged in, a welcome back message is displayed, or it shows a message asking the user to log in. Since this example is too trivial, let's move to the project exercise and see what the challenge is. The ask is to add a favorite feature to our recipes, for which we need to update the models and mock recipe files to include a new isFavorite property. The expected outcome is when you are finished, the web preview should show a star or a favorite text next to the spaghetti carbonara because it's the favorite, but not next to the caprese salad. Let's give it a try. In the recipe model, we have added the isFavorite boolean, and in the mock recipes, we added one more property to the existing object, one with a true and the other with a false value. In the recipe list, we need to conditionally show a star based on this flag. Since after the refactor, all the details were moved from the recipe list to the recipe detail HTML, let's try providing this logic in the recipe detail and see what the Gemini CLI says. Let's create an @if recipe.isFavorite, then display a star. In the web view, corresponding to the spaghetti carbonara, there is a star, whereas for the caprese salad, there is no star. So functionality wise, we know that this is working, but let's see what the Gemini CLI says. It seems there might be a slight misunderstanding about where the @if block should be placed in your current setup. The goal for this module is to use the @if to display a visual indicator next to the name of the favorite recipe. Since the recipe's name is currently displayed within your recipe detail component, the @if block would logically go there to affect that display. Let's confirm the same. It verifies the recipe-detail.html and says, excellent, you have successfully implemented conditional rendering with @if to display a favorite indicator next to the recipe name in your recipe detail component. This shows a great understanding of how to make your UI react to data changes. If you have reached till this point, kudos, you deserve a pat on the back. We are moving to the final phase where we touch upon some advanced features and architecture. In little under 2 hours, we managed to knock off quite a lot of concepts. Next on the list is two-way binding. We discussed about the data flow rules some time back where we learned that data flows down and event flows up. One of the biggest challenges in modern web development is to keep the UI in sync with the data. While we can achieve the same with a combination of a property and event binding, writing extra code make the template and the logic files load faster. With Angular's two-way binding, it keeps the UI in sync with the components class without extra code. To unlock this feature, we need to register a particular module called forms module. Once that is registered, all we need to do is to use a special syntax called banana in a box syntax, which is a syntactic sugar for a combination of property and event binding. It may sound confusing, so let me demonstrate the same. Here is the project challenge for this section. The objective is to add a search input field to your recipe list component. Use two-way binding with ngModel property binding and ngModel change event binding to bind the input's value to a new search term signal in your recipe list component. Import forms module into the recipe list component. Create a new computed signal called filtered recipes that filters the mock recipes based on the search term signal. Finally, update the recipe list component's template to display the list of filtered recipes. The expected outcome is that when we are finished, your recipe list component should display an input field. As we type into this field, the list of the recipe names displayed should be dynamically filtered, and clicking on a filtered recipe should set it as the active recipe for the recipe detail component. Let's give it a shot. Of all the exercises we had till this point, this is by far the most challenging. Let me first show you a finished piece of what the expectation is. We have a search recipes input. Let me type something into the input field. So based on whatever we have searched, it should shortlist the recipe. Clicking on that should show the selected recipe. That is the expected functionality. To build this, let's start from a clean slate. We will remove everything from recipe list HTML and logic and fill them up piece by piece. As I said, let's start from an empty clean slate. I've cleaned everything in recipe-list.html and recipe-list.ts. Now let's start writing the logic first, and then we will go to the HTML file. Step 1 is to add the comments so that we have a reference. We need to add two signals, the recipe and the search term. Then we need a computed signal for handling the filtered recipes. Then we need a method to handle the event binding for ngModel change. And finally, a method to handle the click event when the user selects the name from the filtered list. Let's bring in the forms module and register the same within the imports array. This will unlock the ngModel property binding as well as the ngModel change event binding. Those comes from this module. Step number 1 is to bring in the recipe signal. So let's do protected recipe equal to a signal. Now this should have a type. This can be either a recipe model or null, and let's start with the initial value of null. Then comes the search term. Let's do protected search term equal to an empty signal. So since we haven't started typing anything into the search term, this has an initial value of an empty string. Then comes the computed signal. Let's do protected read-only filtered recipes. So once the user starts typing into the input field, we need to iterate through the mock recipes and filter them based on whatever we have typed. To handle that, we need a computed signal. So we have filtered recipes, and let's assign this to a computed signal which accepts an anonymous function and let's do const term equal to this dot search term dot to lowercase dot trim. So whatever we have typed, convert that into a lowercase and trim it so that if there is white space, let's trim that down. At line number 22, what we have is the search term. If there is no search term, return an empty array. So if the user has not typed anything into it, please return an empty array. Else, return mock recipe. So get the mock recipe array, call the filter method, and for each item in that array, get the item dot name, convert that into a lowercase, and see if that starts with our search term. This completes our computed signal. Now all that is left is two methods. Let's start with the handle forms change method. This will accept a value as a string. So whatever the user typed into the input field, that value is captured here using the handle form change event handler. Within that, let's call this dot search term dot set and set this value. So initially the search term was empty. Once the user starts typing into this particular value is set into the search term signal. The last method is handle selections change. When the user selects a recipe from the filtered list, this method should handle it. It should accept a recipe which is of type recipe model, and once that is done, it should set the recipe signal to whatever the user had already selected. Currently it's null, and once the user selects the same from the filtered list, that should be set as the recipe signal. And once that is done, let's set the search term back to empty string. Moving to the recipe-list.html, let's start with a div with a class of recipe-list. Within that div, let's have one more div with a class of search-section. Within the div, let's have a header of h3 with a class of search-header and the text search recipes. Underneath the h3, let's have an input. This is of type text with a class search-input and with a placeholder type to search. Now let's bring in the property binding and the event binding. Let's do the ng model and bind that to the search term signal. Let's also bring the ng model change event binding and bind it to the handle forms change event handler. So whatever the user types is getting passed into the method using a reserved property called $event. If there is something to show once the user starts typing, let's do @if filtered recipes.length greater than 0. So once the user starts typing and it goes through the filtered recipes, and if there is something to show, then let's have a div with a class of filtered-recipes. Put a UL inside that. Let's iterate through whatever the filtered recipes are. So put an @for. Let's iterate through the filtered recipes. So recipe of filtered recipes. Since the for loop need a track, let's do track recipe.id. So this is the unique ID that tracks the individual items. Within the for loop, let's put a list item with a class of recipe-item, a div with a class of recipe-item-info, and within the div, let's have a span with a class of recipe-item-name. Here we bind the recipe-name. And the last thing to do is to have a click event bound to the li. And let's call the handle selection change and pass whatever the recipe the user has selected. Once there is a recipe available, then let's pass that recipe into the app-recipe-detail component. The exclamation mark here is to make sure that TypeScript doesn't complain since we start with an undefined or a null. Here we are explicitly saying we know that this particular component needs a recipe, and we will make sure that we pass that recipe to the app recipe detail component, and TypeScript shouldn't throw an error here. And to verify if this is working or not, Let's move to the web view, type S, click on spaghetti, and we can see that the respective recipe is already loaded. Let's type C, click on caprese salad, and see that that recipe is also selected. So the functionality is working fine. Let's head back to the Gemini CLI and say done. Alright, it said, excellent. You have successfully implemented two-way binding for a search input, filtered your recipe list using a computed signal, and dynamically displayed the results. This significantly enhances the interactivity and usability of the application. At the start of the section, I touched upon a weird syntax called banana in a box for two-way binding. This syntax can help avoid adding pair of property and event binding to achieve the same two-way binding functionality. Let's see how that is done. Instead of having separate property and event binding like what we see here, we can club them together and use it with one syntax like this. I can remove the ng model change and I can put a bracket like this and omit the invocation. This is the equivalent of what we had before. Since we don't need the event handler, we can also remove that event handler from the TS file. If we head back to our web view, let's type C, click on caprese salad, it shows. Let's type S, spaghetti carbonara, it shows. So the functionality is working exactly as it is, but with less code. That's it for this video. Let's move to module 14 where we discuss about service and dependency injection. We are almost approaching the end of the playlist, just 3 more modules to go, and the bigger topics, that is service, routing and forms, are the topics which are coming in the upcoming playlist. Before that, it's essential that you are comfortable with the topics covered till now. When I was learning these topics initially, it was tough to get my head wrapped around few of these concepts until I practiced them a few times with smaller examples. So please pay attention. See you soon in the next video. Thank you and bye-bye.